This is House Planning Help episode 17.
Have you always wanted to build your dream home? Maybe you know what you want. But what if it could be better? HousePlanningHelp.com. Speaking to the experts, searching for better ways, planning for the future. Build a better home. HousePlanningHelp.com podcast.
Hello, I'm Ben Adam Smith, and today we're looking at whether a ground source heat pump can make a period property energy efficient. My guest is Justin Broadbent from ISO Energy.
HousePlanningHelp.com.
A warm welcome, thank you for downloading, and if you haven't heard the podcast before, this is the first one you're checking out, then why not? You might as well start on this one. It's a podcast for people like me who are wanting to build or renovate an energy efficient home, and you just want to build up your knowledge to begin with. It can be quite overwhelming, so I'm not saying that I take the most straightforward path here, but my approach is really this big long list of questions that actually seems to get longer and longer. No matter how many different episodes we have, that list increases. And maybe there's something that you want me to address as well, and you can add to that list by emailing me. I'll give you my direct email address. It's ben@houseplanninghelp.com. But that's our approach. We chat to the experts or people who have been there and done it and try to learn from their experience. So let's meet today's guest.
HousePlanningHelp.com. The interview.
I'm with Justin Broadbent from ISO Energy, and today we're going to talk about ground source heat pumps and also listed buildings or very old buildings where the fabric of the building is actually quite difficult to adapt. Before we start though, hello Justin.
Hello, nice to meet you.
And maybe you could tell us a little bit about your story, how you became interested in this area and took it forward to the company ISO Energy.
Mm-hmm. As it goes back about probably about 14 years now, I had a software company that I sold and semi-retired and needed something to do. And I live in amongst other places, I live in a house that's built in 1726 or thereabouts, heated on oil. Probably about as efficient as Stonehenge when I took it on, and quickly realised that we needed to do something with it to reduce the running costs. Really, in those days, I'm an engineer by trade, and so I'm interested in these things. And I had a father-in-law who was a partial owner in a Swedish manufacturer of heating systems, and I just started getting generally interested in what could be done to get rid of my dependency on oil. Whilst I was learning about that in Sweden, of course, all houses are hugely more efficient than they are in the UK. I mean, embarrassingly so much so. And these people started talking about insulation levels and things like that. And I was thinking, insulation levels, what's all that about? And quickly realised that there's such a vast difference between what they were doing in Sweden and what we're doing here, that I've begun to realise that actually it's not all just about plugging in some mechanical thing to try and reduce your heat losses, your running costs. It's also about trying to reduce your heat losses in the first place. And so that's how I got started, really. And I started more or less as a consultant to people and then importing in machinery. And then people started saying, well, who installs this for us? And so we started doing the installs as well. And now we are fundamentally designers and installers of renewable energy systems of all sorts. But I particularly like heat pumps. That's my own personal favourite. But I have to say it's all about horses for courses, and we have people in my office that prefer biomass, for example, to heat pumps. I actually think you've got to look at what you have available, what resources you have available to you, and the best match for your requirements is what are we looking for.
What is a ground source heat pump, or maybe it should be a heat pump first of all?
Yeah. I mean, the glib answer to that is, well, everybody already has heat pumps in their houses. You have a fridge or a freezer, it is actually a heat pump. And all that a heat pump does is to compress energy. If you take it to its very basic level, a bicycle pump, if you pump up your bicycle tyre, you will probably feel that at the end of the bicycle pump it starts to get warm. That is because as you're compressing the gas from ambient air pressure of 1 bar through to 5 bar or whatever you're putting into the tyre, the molecules get excited because they're under pressure, and so they get warm. And so a bicycle pump is actually a heat pump, believe it or not, in the time when it's running. Your fridge is a heat pump. You're taking the ambient air temperature out of the kitchen, let's say at 18 to 20 degrees, and compressing that heat, radiating it out at the back of the fridge. So if you feel the back of a fridge, it's normally at about 40 degrees. in engineering, there's always an equal and an opposite to everything. So if we're generating heat, we're also generating cold. Now, with a fridge freezer, you keep the cold and throw away the heat, but it doesn't matter because it's going into the kitchen, which you want to heat anyway. With a heat pump that's going to heat the house, you effectively keep the heat and put it in the house and throw away the cold, which goes outside. If it's an air source heat pump, it goes outside into the air. If it's a ground source heat pump, we put the cold into the ground.
How would you know when to use one for a house?
That's a difficult question. It depends on the house. It depends on all sorts of things. At the end of the day, most things come down to pounds, shillings and pence at the end of the day. Most people get interested in reducing energy because of the cost. Some people, of course, want to do it because they're green. And I think being green is certainly a driving force. But most things are driven by cost at the end of the day. And if you have an oil bill that's costing you, 5, 10, 20, some of our clients are spending 70, 80,000 pounds a year heating their houses, and you're trying to reduce your 3,000 pound a year oil bill or whatever, you can put in a heat pump and you might typically be able to reduce your running cost by about 2/3. Certainly half for sure, probably more like 2/3, in certain circumstances even more. So if you're, say, spending £5,000 a year to pick a subject, and we can reduce that down to £1,500 a year by putting in a heat pump, then it's probably worthwhile doing. That is the driving force in most cases.
The reason that I was quite keen to do this episode is because of certain properties where you can't adapt the fabric. We've done quite a bit of research into this, looking at insulation. You mentioned it yourself just now in Sweden, that they're so much better than we are at doing this. So what do you actually need to make it happen?
Almost inevitably, you can always improve the fabric of a building, even if it's grade 1 listed. I mean, I live in a grade 2 listed building, and obviously the controls are a lot less on that. And there aren't that many grade 1 listed buildings anyway. But even there, you can insulate the loft. You can insulate the cellar quite often. You can stop cold coming up from the cellar. You can stop the cold ingress from the roof. Most grade 1 listed buildings nowadays had shutters built in because, of course, when people were building these buildings, there was no free energy or gas and things like that. And so it all had to be done manually, and you had to keep the house warm. Well, often you had walls that are, meters thick and shutters on the windows. Well, shutters on the windows are extremely good insulators. It stops the drafts getting through. It's a windbreak. The wind hits the glass and gets round the glass. It then hits another barrier, and by the time it's got through the glass and the shutter, there's very little power left in that wind. And equally, wood is the second best natural insulation there is, wool being the best. Wood is then the second best. And so you're effectively got a half-inch layer of insulation, thick insulation, between the outside world and your house. So generally speaking, with these old buildings, you should go back to trying to use them as they were originally designed. You should close your shutters at night. And those rooms that are sealed off and not being used very often, if you live in a very large house, keep the shutters closed when you're not using it. Use the fireplaces, light them. Some chimneys draw very, very well and don't create any drafts in the house. Some chimneys aren't so clever and you get a lot of drafts in the house. So if you have a very drafty chimney, block up the chimney when it's not being used, or try and light a fire in it and get the draft going the right way. Secondary glazing, you might or might not be allowed to, depending on your conservation officer, or depending on whether you like the idea of a secondary glazing or not. But I mean, as you see here, we're sitting in my drawing room here. I have secondary glazing here. I don't think most people would know it was there. And when you do point it out to how it is when you take it out, you suddenly realise how good it is.
It might be worth actually saying how you've done that secondary glazing.
Yes, well, this we did actually 20 years ago now. Actually, not quite 20 years, 18 years ago probably. Our windows are wooden frame rather than stone mullions or whatever. It's a wooden frame window with leaded light windows and sprung-loaded pin hinge windows. So there's no normal catches and things like that. So really, when it is windy, it is a little bit like Stonehenge, trying to heat Stonehenge here. And in front of the old oak frames, we have a very thin oak frame going around with, in this particular case, just a single paned glass. But rather than it being, we've taken the whole window area, as you can see, rather than each individual pane. And so really it's just a one big shade piece of glass that's probably, 6 feet by 2'6". If we're looking at this window here, and you really, until you touch it, you can't see that there's even a window there. So you think you're looking at the old-fashioned windows, aren't you? But in fact, there's another set 6 inches in front of them in this particular case. And it works very well. The room becomes really quite cosy. No noise, no heat losses or drastically reduced heat losses.
So that's the first step, to see what you can do. Are there any situations where you're not sure what to do? Say, for example, the walls. If you wanted to insulate these internal walls here, and we know about interstitial condensation, and obviously the planning office is going to say, no, you can't do that. But how far can you go with all of those processes that we've talked about?
Yes. The first thing is insulation. Estate agents go around saying location, location, location. In my mind, nowadays, I think to myself, insulation, insulation, insulation. And the reason for that is that, the glib truth is that the most expensive heat you put into the house is the heat that you're putting in the second or the third or the fourth time, because you've lost it the first time. So whatever you can do to stop the heat losses, it's just to use a really horrible term, it's a no-brainer. You should just do that. Having said that, there are limits. I mean, we live in these houses because they're beautiful houses. I don't want to have a wall that's just a layer of insulation and is very plain. I like these beams. I like to see them. And indeed, the conservation officer would have something to say about it if I tried covering them up. And I do, believe it or not, in some areas here, and often houses do actually have cavity walls in certain areas. The cavity walls go back a long time. But this is an oak-framed house. I refuse to insulate my cavity because these beams have stood here for hundreds of years. And if you get any damp bridging in them at all, they could rot in a decade. And so I'd rather spend an extra 20% heating my house and know that the walls remain secure. So we don't insulate. I haven't insulated, and often I tell people don't believe what you read about insulating in cavity walls and things like that. In listed buildings, you can't do anything other than that anyway, because you wouldn't be allowed to clad them on the inside or the outside normally. So I haven't insulated my walls. However, you can just see how thick those walls are. I mean, that wall is 1.5 feet thick, on minimum, really, everywhere. So you never want to insulate an internal wall, especially if you're running renewable energy, because the way that we heat this house and the way that we advocate our clients' heating is by using a term weather compensation, which we'll probably talk about in a minute. But weather compensation means that we try and bring the house temperature up to a temperature, let's say 20 degrees for argument's sake, and then keep it there. And what that means is that the whole house gets to 20 degrees and stays there year in, year out. That means that my walls are also at 20 degrees. Now, if it gets -6 and blowing a gale outside, my inside walls are at 20 degrees now. So they actually act as a radiator when it gets cold outside. But if I insulate those walls, then I can't actually get that thermal mass that you require. And these houses were designed around thermal mass, and people have sort of forgotten that. And by putting in modern radiator systems with boilers that fire up at 6 o'clock in the morning and put 80 degrees around the radiators and then go off at 10 o'clock and then come back on again at 3 in the afternoon and go off at 11 o'clock, and the buildings are getting warmer and colder and expanding and contracting all the time, and actually doesn't do them very much good. What we do is we actually try to live like they were originally designed to, but the original design required you lighting a fire all day long, but you would have had staff that did that. It was easy to do in those days, not so easy nowadays. But the place would have been, each room would have been used individually, and it would have been kept at a relatively low temperature by today's standards, but at a fairly constant temperature, probably around about 15, 16 degrees. The only difference is nowadays we all like to walk around in thin shirts and slippers, or no slippers even, and so we want our rooms at 20 or 21 degrees. Well, what I try and do is emulate how the house was designed, but bring it up to modern standards by trying to use the thermal mass of the building, and that is quite important. And if you insulate badly or in the wrong area, you can actually get rid of the thermal mass, which is a good quality to have in these old buildings.
Let me just clarify that for a second, because I've only learned this quite recently, but there are two approaches that you can go towards a low energy building. One of them is to do with thermal mass and using that, heating it up, and the other is more of a super insulation approach.
Yes, and you can't get the super insulation approach to work with a listed building. It's just not going to. Well, I mean, there are listed buildings that are actually quite modern, but 99% of your clients are going to be living in old buildings. So you have to go with the thermal mass route. It is the only way. But it is incredibly effective. You know, when they built these houses, they knew it was cold outside. It was probably colder than it is now on average 300 years ago. So these houses were built to withstand cold. And obviously the staff, you had staff to help you in those days. But no, the concept of thermal mass works very, very, very well.
Getting back to ground source and air source heat pumps, What do we need to do to the house or outside the house in practice?
Okay, very little is the answer, including a lot of people say you have to oversize the radiators and things like that. Well, you can see here, I mean, I have one radiator over there and one radiator over here. They're not particularly oversized. In fact, they're exactly the same radiators that were being used when the house was heated on oil. The difference is that with oil, as I said earlier, you tend to switch them on and switch them off, especially if you think you're saving money. What we do is try and put in a lower amount of temperature, a lower grade of temperature, a lower temperature setting, but for a 24-hour period. And so all we're trying to do is maintain temperature. Once we brought the house up to temperature, which is the hard work, so it can do it itself in the summer, we just then start maintaining that temperature through the winter. So rather than the radiators getting up to 70, 80 degrees, these radiators probably never go above 45 or 50 degrees, but they're at 50 degrees all day and all night.
Why doesn't it overheat in the summer?
Oh, the heat pump will. What happens? What we use is weather compensation. Now, there are no thermostats in this room. What we have is a system whereby the only sensor is actually not in the room, it's actually outside. And then we have a series of algorithms in the brain and a control system that work out what is the temperature outside, what is the flow temperature to my radiators, what is the heat loss or the return temperatures from the radiators. And the algorithms then work out that if it's got a maintaining, let's say, a 4-degree delta T temperature differentiation between what I'm putting into the radiators and what I'm getting back. If the temperature outside drops by a degree, then it'll notice that 4-degree difference inside will maybe go up to 5 degrees. So it puts a bit more energy in to close that gap. And so all it's trying to do is constantly monitor what the temperature is outside. And as it drops faster and faster outside, it starts putting more and more heat into the building. And as the temperature then starts going up outside, it puts less and less heating into the building. So when it's -7 and blowing a gale outside, my radiators probably get up to about 60 degrees. But when it's +14 outside, they're only running at 32 degrees. Yeah, so it's called weather compensation. The colder it is outside, the more energy goes into the radiator. It's much more sophisticated than you can do with a boiler, because a heat pump ultimately runs on electricity, so you can run it like a computer and it will work out what's happening.
I can tell you're probably a gadget man, but having all of this technology, is it a lot to go wrong, and it's only because of this particular situation that we'd have this solution?
No, in fact, actually, there's a lot less to go wrong with a heat pump than there is a boiler. A boiler requires all sorts of things to make the oil flow and dirt get trapped, and 1,000 degrees of flame trying to heat up a heat exchanger and things like that. A heat pump is simply a small compressor that runs almost 24 hours a day. How reliable? When people say how reliable it would be, well, if it's done properly, and the biggest problem we have in this country is that there are, I'm afraid, a number of cowboys out there, but if it's done properly, a heat pump will be as reliable as your fridge. Well, I ask people, if you buy a decent quality fridge, when was the last time it broke down? You probably don't know. Most people replace their fridges not because the compressor breaks down, but because the door handle falls off, or the seal breaks, or they don't like the shape of it anymore, or they're building a new one into a kitchen. Fridges are very reliable. Well, heat pumps should be very reliable as well. The problem with them comes when you try and push them into areas where they shouldn't be, or you install them badly, or badly sized groundworks is the biggest problem normally in this country.
As a client, how do I know that the contractor is going to do all this correctly? Because it's way above my head. That is a really, really, really very difficult question to answer. I mean, the glib answer to I would have to say was come and see me. That's all right. Yeah, okay. There aren't very many people that know what they're talking about when they're trying to put them into listed buildings, and there are only 2 or 3 companies that really know what they're talking about, and there are only 1 or 2 that actually do a decent job, and I say that myself. But you're here because you've been told that we do a good job, so I think I can say that. The problem that most people have with this is that they don't understand where the energy comes from. They think that somehow it's magic. Well, it's not magic. There is an engineering reason why it works, and that is that you're taking low-grade heat out of the ground. Forgetting about air source heat pumps, we're concentrating on ground source heat pumps at the moment. You're taking low-grade heat out of the ground. And if you say, for example, that your house needs 500,000 kilowatt hours a year to heat through the winter period, I've got to somehow get 500,000 kilowatt hours out of my ground. Well, to put that into some sort of scale, a 3-bar electric fire uses 3 kilowatt hours an hour.
So if I need 500,000 kilowatt hours, I'm going to take it out of my garden. It doesn't really sort of make a lot of logical sense, does it? So what that generally indicates is that the scale of these things is misunderstood. On a house of 1,000 square meters, the average house of 1,000 square meters, we are probably putting in 5-6 kilometers of pipe into people's gardens. The next problem is that the pipe must be broadly spaced, because if you put too much pipe too close together, all that's going to happen is you're going to take 500,000 kilowatt hours out of a tennis court and it'll turn into a block of ice. We need to take that 500,000 kilowatt hours out of a 5, 6, 7, 10, 15, 20 acre field. The larger the better. The more we spread the load on the garden or the field, the more efficient it will be.
We've talked a little bit about how it can go wrong, but are there specific things that you always think, oh dear, this person has done this wrong?
Yes, I mean, normally it is all about the civil engineering. It is understanding how much energy you can take out of any area. It matters a lot how much water there is in the ground, how much of a slope there is on the ground, what the ground is. Is it shale? Is it sand? Is it wet sand, dry sand, chalk, clay? All of these substances have different heating properties and different heat transfer ratios. And so it's important to understand what they are and do the calculations properly. Equally, it's important to make sure that the turbulence in the pipe is right so that you can extract the heat properly, and that the flow pressures are right. For example, I often see people, that might even have fully understood that you need 3, 4, 5 kilometres of pipe in the field, but the flow and return is also in its 40 mil pipe, say, but they've done the flow and return in 40 mil pipe out to the field, so the pressure losses are so large you need a 3 kilowatt circulation pump to push the stuff around. The idea is to try and be green, so we don't want a 3 kilowatt circulation pump, we want a quarter of a kilowatt circulation pump. But that then means that you need transfer pipe that's 130, 160 millimetres in diameter, which is like a drain pipe, which of course is a lot more expensive to lay than 30 or 40 millimetre pipe, and so it goes on. It's all about understanding pressure losses, understanding heat curves, understanding the algorithms that you need to do and as I say, I'm an engineer, so I think it's fun. I'm rather sad, really.
And they're all different, aren't they? There's not just one heat pump.
No, gosh, no. I mean, there are 15, 20, 30, 100 different manufacturers of heat pumps. Suitable for the sort of work that we do, there are 3 or 4.
For the work that you do, there are only 3 or 4?
The sort of houses we're talking about here, there are only 3 or 4 manufacturers that I would actually build heat pumps that are the sort of diesel engines of the heat pump world, because what we have here is a large load that's going to be spread over a long time. Some of your listeners will live in 4-bedroom 3 up, 3 down houses, are well insulated, and they probably start their heating in end of October and they switch it off again in the middle of March or whatever. Often these houses that we live in, the heating season starts at the end of middle of September and goes on all the way through till the middle of May, March. Forget turning off the heating in March; it's at its peak almost by then. So it's a very long season. It's a lot of energy coming out over a very long period, and these heat pumps are going to work hard. So you've got to have commercial heat pumps, really, I guess, is the way to think about it.
Let's just finish off with, if you have a top bit of advice for a person who's got their listed property or something that they feel they've done as much as they can with the fabric, what should they be thinking about next?
Well, if you've done all that you can with the fabric, I mean, lifestyle, of course, is the main thing. Apart from fabric, is just try, as I say, shut the shutters up, learn to live economically. I think is the best thing to do. But if you then got past all that and you think you've done as much as you want to do, and of course, what you want to do is some people want to live at 25 degrees in the room, in which case that's what they should be allowed to do. I mean, I'm not saying, but be aware it's a lot more expensive to do that than if you're prepared to live at 18 degrees. I actually like to live at 20. This is set at 20, and that's where it stays all the time. And which does mean I can sit and watch television in a shirt. After you've done all that, then you've actually got to analyse how much you're spending on oil. If you're on oil at the moment, how much you're spending on oil. Are you happy with that? Because if you are, it's just carry on paying it, unless you're wanting to be really green. If, however, you want to be green, and if you're not happy with the amount you're paying on oil, then you've got to evaluate your circumstances as to what is the best solution for you. And there are lots of solutions out there. I mean, there's ground source heat pumps, which we've been talking about, and I'm obviously a fan of. Air source heat pumps, I'm not quite such a fan of those, but they do have a place. Biomass boilers, which means burning either logs or wood chip, or worst case scenario, wood pellets. Do you have a stream running side with a good flow and a good drop in it, in which case a hydro system is a good idea, that they really can pay back enormously quickly. And obviously the other thing to be aware of always is government grants. Everyone's heard of, everyone's seen PV panels going up on people's roofs and the feed-in tariff that you get from that. There are also feed-in tariffs for hydro systems, so if you have water wheels and things like that. And the government is bringing out the renewable heat incentive, which will pay people to replace their oil-fired boilers with heat pumps and biomass boilers with which to heat their houses. And those grants are actually looking like they're going to be particularly generous. So we're rubbing our hands together with glee as business people, but as a taxpayer, I object to subsidising everybody else's houses. But no, the heat incentive is one of the things to really keep an eye on, because it will mean that you'll be able to heat your house not only for free, but you'll get paid to heat your house for the next 7 years, the way it's looking at the moment. There is, of course, an upfront cost of putting in the equipment in the first place.
Well, Justin, some great information today. Thank you very much for your time. And that's something else that we've got to take on board.
No problem at all. Nice to speak to you.
Another industry expert on houseplanninghelp.com.
It's a real privilege of doing this podcast that I get to go and see a lot of these properties firsthand. So I thank Justin for his time, and you can find out more information about ISO Energy in the show notes, houseplanninghelp.com/17 for this session. Facts and figures on a few of their projects as well. So lots of really good information. And at the bottom, you can leave a comment, as we always try to encourage you to do. If you do like podcasts, which perhaps you do because you're listening to one, then I'd like to recommend one to you. And this is one that I've discovered only recently. In fact, it was after we did our episode on climate change. If you go back and listen to episode 15, I told you about my content marketing idea and how I felt that we could really harness the influence from content marketing. But Matthew Cutler Welsh got in touch. He's an engineer based out in New Zealand, and he's passionate about the natural environment. But he has a podcast called Homestyle Green. And I've only listened to a few episodes, but I'm really enjoying it. And it does seem that we've got so much common ground. So I can't wait to get him onto the podcast, and we'll have a chat with him and find out a bit about the situation in New Zealand. I know that this podcast is often focused on the UK, but it's because I'm based here and the experts, a lot of them are based here. But we do hear about examples in Germany and Austria and Sweden and Denmark and Holland of where they're doing really good things. But it'd be nice to know what's going on in New Zealand. So hopefully that for a later date, and we'll put in a link to Homestyle Green if you want to go and check out that podcast. My one call to action is to subscribe to our email newsletter. And why would you do that? Well, I'll give you 3 reasons. Firstly, it's got even more helpful information that's not available on the website or the podcast. We reserve that in the email newsletter. Also, we let you know about new episodes as soon as they're published, so you can go straight to that information. And we tell you about future guests up front. So before we'll publish that on our social media links, we tell you about that. So head online, houseplanninghelp.com, and sign up to the email newsletter. It's really good. We try and make sure that it's positive information. I know there are so many email newsletters that are just a load of rubbish. We try to really up our game so that every email you think, wow, he sent me this and he's not charging for it. What a nice guy. Next time, well, we're coming up in the UK to EcoBuild, which is one of our big events, so hopefully some news from there. I'll catch up with you soon.
You've been listening to Ben Adam Smith on the path to build a better home. Sign up now to the free email newsletter. Head to houseplanninghelp.com.